Good afternoon, students. Okay, good afternoon, students. So today we are explaining about the DSP lab. So in that we are having 9 experiments. So among these 9 experiments, the first 2 experiments is regarding here. The first experiment in DSP lab is linear convolution. The second experiment is circular convolution. So total 9 experiments are there for MATLAB. And remaining 3 experiments belongs to non-real time and 1 experiment is for real time. Non-real time, again you can go for circular convolution, linear convolution, endpoint DFT. And finally, real time, the FIR filter for low pass filter using CRO. So first you can go for our first experiment. Just see here. Just you can observe here. In our laboratory, our first experiment is linear convolution between 2 sequences. So the MATLAB software is we are using here. Just observe here algorithm. Convolution of 2 signals, we need 2 samples. One is X of n, another one is H of n. X of n is the one sample and H of n is the impulse sample. So like this, X of n is one signal sequence, say H of n is another sequence. Just both are convolution, you can get Y of n. The limits are taken from 0 to infinity, X of k star H of n minus k. So in MATLAB, we are having the facility for convolution without any mathematical calculations just by using this command conv x comma h. It performs the convolution for x and h, and resultant is stored in y of n. So that can be performed by your program. Just observe here. First, initially we are taking first input signal xsi equal to input, and then the starting index of the input. Starting index means you can consider as here test data -1. So -1, 0, 1, 2, 3 like this, starting index. Next HSI impulse signal, starting index of the impulse. So you can take it as both are in different way, -1 and -2. So starting index of input signal is given as -1 means here the signal is, just observe here, X of n starting from -1, 0, 1, 2. And H of n is starting from -2, -1, 0, 1. So samples are starting at index. So I have to specify that index. Next, X is input. Enter the input sequence. Input sequence we are taken as 1, 2, 3, 4. H input. Enter the impulse response. Impulse response is 1, 1, 2, 1. Next, by using this MATLAB function, y equal to convolution of x comma h, we can get y. Next, n1 is xsi is to 1 is to length of x plus xi minus 1. So xsi, starting index of xsi here take it as -1. So length of x, length is considered as 4. So -1 here, 4 minus 1. 4 minus 1 means 3. 3 minus 2. So like this, initial value, and here xsi indicates initial value, and one is increment. X is the initial value, one is the increment, this is final value, length of x. So length is considered as 4. Next, plus xsi. Xsi means here -1, -1. So 4 minus 2 equal to 2. So n1 is 2. Similarly, n2, you can find out HSI. HSI is here, you can consider as -2 is to 1 is to, what is the next one? Length of h plus HSI. Length is here also 4. 4 plus 4 minus 2 minus 1. Therefore, 4 minus 3, it will be 1. That means, what is the reason means, first exercise is, initial value is -1 is to 1 is to 2. And HSI is -2 is to 1 is to 1. What does that means? Initial value is x of n is -1. Increment is 1. So -1 plus 1 is 0. So like this, here -1, 0, 1, 2. Starting index is -1, ending index is 2, increment is 1. So -1 plus 1 is 0, 0 plus 1, 1, 1 plus 1, 2. Similarly for h of n, Starting index is -2, ending index is 1, increment is 1. -2 plus 1, -1, -1 plus 1, 0, 0 plus 1, 1. So that is information. Here we are written N1, N2, and N3. N3 is nothing but output Y. So substitute XSI, HSI, length of H, XSI plus HXI. That means we can get -3 raised to +3. -3 plus 1. So -3 here, the increment is considered as 1. So -3 plus 1, -2. Next, -1, 0, 1, 2, 3. So these are N1, N2, N3. So after getting these values, subplot. Plot means we can draw in the graph between X and Y. Here subplot means 3, here 3, 1, 1 means 3 rows, first column, first figure. 3 rows, first column, second figure. 3 rows, first column, third figure. So first one, X of n, H of n, Y of n. So it is a simple program. Just you can take, after entering this one, just in MATLAB, you can just store this one. Any label is given as just like as your program name. Otherwise, you can go for any name, project name. And after that, you can go for run. At that, they are asking enter the starting index. So first you have to enter -1. Next, again enter it is enter the starting index of impulse -2. Enter the input sequence. So within the bracket, we have to keep like this 1, 2, 3, 4. Enter the impulse response within the bracket 1, 1, 2. So you can get answer is y equal to 1, 3, 7, 12, 12, 11, 4. So it is a mathematical calculation. We are given the answer. The same here we are using subplot option. So based on subplot option, you can get this 3 graphs. So first one X of n, one input signal, H of n, another input signal, and convolution between X of n and H of n, you can get Y of n. So that is your first experiment. Next one more. You can go for unmade here. Next one is experiment 2. So just we'll wait. Now you can go for the second experiment.